Okay, somebody walk me through number 2. What's the domain and range for number 2? What's the domain for number 2, Diego?
2, 3, 4.
And then what's the range? 3, 5, 7, 9. How do you figure out what that equation is? Because some people are saying, well, I can't do that because it's like +1, +2, +3, +4. So that didn't work. So Rodrigo, what do you have to do?
Multiply by 2 and then subtract by 1.
You've got to multiply by 2 and subtract by 1. So your equation ends up being y equals 2x minus 1. How do you figure that out, though? If you had to give somebody tips for how to figure that out, if you're just stuck, rather than just saying like, oh, well, this is the answer, how can you help somebody figure that out? Rodrigo, what do you think?
Like for the first one, you said 2 times 2 equals 4, and the second one equals 3.
So you just start trying things to find the pattern, right? And you know that this number is getting what? Is this number getting bigger or smaller? Like to go from 2 to 3, does that get bigger or smaller? Bigger? It gets bigger. So you're probably going to have to use either multiplication or addition. Addition won't work because we just saw that you can't just add. So as soon as you see that you can't just do one thing, you know that it's going to be a multi-step equation. So if you multiply by 2, then you have to subtract by 1. So when you're looking for how to do these problems, what I would advise is take a look. Is it getting bigger or smaller? If it's getting bigger, you probably need to use multiplication or addition. If it's getting smaller, what kind of math do you think you need to use? Subtraction or division. Good. So that's like my first tip for how to figure it out. And if you ever can't do it in one step, just start thinking most equations look like this. Mx plus b. Most of them are in that slope-intercept form where there's something times x plus or minus something else. So a typical equation in linear form is going to look like that. All right? It's going to look like this. Something in front of x plus or minus something else. So when you're looking for what an equation could be, it's probably going to be in that format. All right. So we are going to talk today about how to graph functions. So we've been looking at different functions, and we've looked at how to write equations for them, and we've written them in the format y equals something, 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 or y equals mx plus b in that linear format. And when we want to graph something, we have to figure out how to put it onto a coordinate plane. So how do I do that? How do I put something onto a coordinate plane? To do that, I need what? I need ordered pairs. What is an ordered pair? What is an ordered pair? Brendan?
An ordered pair, it's like coordinates.
Okay, it's a coordinate. What does it look like? If I were to write one, what would you tell me to write?
I would tell you to write 2 and 4. So 2 comma 4.
2 comma 4? In parentheses. Good. So an ordered pair looks like 2 comma 4 in parentheses, where the 2 is which variable? X, and the 4 is y. On a coordinate plane, so on this graph in the corner right down here, on a coordinate plane, the x is what? The horizontal or the vertical? Horizontal. Good. And then what's the vertical? The y. So when you plot a point on a coordinate plane, you plot the x first and then the y. So in this case, you would plot the 2 first and then you'd plot the 4. All right, but what would you do if you just have an equation like this and I say graph it? If you just have an equation like this and I say graph it for the given domain, the domain is which variable? The domain is which variable? Montreal? It's the x variable, right? So these are my x values, but I can't just graph with x values. I need an x and a y, because Brendan said I need an ordered pair, I need to have 2. So what would I have to do then to be able to graph this? What do you think, Alejandra? Exactly, plug them in, and each one of those is going to give you a different ordered pair, right? So the first thing you're going to do is plug all of those in for x. But we don't usually look at equations in this order, right? We usually have the y where? In the front by itself, right? So before we do anything else, I want to get the y by itself. So I'm going to give us a little bit more room here. All right, and I'm going to get the y by itself. So I've got negative x plus 2y equals 6. What would I have to do to get the y by itself here? I'm going to have to divide at some point, but I can't divide yet. What do I have to do first? Add what? X. I need to move the x. If I add x here, where else do I add it? To the other side, plus x. Are those like terms? So can I add those together? So what do I do? 6 plus x. Good. And then that equals 2y. Now what do I do? Now I'm ready to divide. And I'm going to divide by, and then over here I have to divide the 6 by 2, the x by 2, or everything. Everything by 2. So my equation ends up being y equals 6 plus x over 2. So there's my equation. And now I just need to do exactly what Alejandra said to do at the beginning, which is plug those 4 values in for x. So I want to plug in those given domains. And I've got x and y, and I want to do -4, -2, 0, and 2. If I plug in -4, what's 6 plus -4? 2. 2 divided by 2 is 1. Now I plug in -2. What's 6 plus -2? 4. What's 4 divided by 2? 2. What's 6 plus 0? 6. 6 divided by 2 is 3. And what's 6 plus +2? 8. 8 divided by 2 is 4. And now I have ordered pairs because I have x values and I have y values. So I can plot those onto a graph. So who can come up and plot these onto a graph? I've got these ordered pairs right here. -4, 1, -2, 2, 0, 3, and 2, 4. Diego, can you come do one of them? Brendan, can you come do one of them? George, can you come do one? And then one more person. Can I get one more person to come up and plot a point? So that would be 1, -4. Is that your point?
Yes.
Are you sure?
No, wait. Yeah.
Are you sure?
No.
All right.
Okay. I forgot.
Which one are you doing, George?
Second one.
Okay, so -2, 2. All right. Good. -4, 1. Brendan, you're doing the third. Good. And then can I get somebody to come do 2, 4, Alejandra? She didn't want green. Thanks, though. Okay, good. And now that you've got them graphed, what should you do? You should probably connect them. And you'll notice that these make a what, Matthew? They make a line, so this function is linear. This is a linear function, all right? If they don't make a line, check your work, all right? If they don't make a line, check your work. Because if they can be written in this format, this y equals on by itself, then that, and it doesn't have any exponents, it's a linear equation, which means it should look like a line. So, not that you guys are often wrong, but sometimes you make little mistakes, right? So if it doesn't look like a line when you graph it, just check your work to make sure you didn't make a mistake, all right? And typically, check the negatives. Because oftentimes, that's where mistakes happen, all right? Sneaky negatives. Okay, so again, the 3 steps. The first thing you have to do is get y where? Where do you want y? You want y by itself. So you want y on the left by itself. Next thing you had to do is what? You got to plot the pairs on the graph third. What's the second thing you have to do? Yeah, you got to get the pairs, right? So you got to get those pairs before you can plug them into the graph. All right, so I want to do this one. Try it, f of x equals 2x plus 4. And remember that on Tuesday I said f of x is the same thing as y. F of x is exactly the same as y. So I'm going to rewrite this equation, and instead of writing f of x, I'm going to write y equals 2x plus 4. So do I even have to do the first step, or is that already done? That's already done. Y is already by itself. So I just need to plug in my domain and get my pairs, and then I'm going to graph it. So I need to plug in what values for x? -3, -1, 3, and 5. Good. -3, -1, 3, and 5. So first things first, what's 2 times -3? -6. -6 plus 4 is? -6 plus 4 is? -2. Good. All right. 2 times -1? Negative 2. Negative 2 plus 4 is? 2. 3 times 2 is? 6 plus 4 is? 5 times 2 is? 10 plus 4 is? 14. Okay? So when I go to plot this, it's not going to fit probably on this graph. We're going to have to go a little bit outside of it. But when I go to plot this, what's the first order pair I'm plotting? Negative 3, negative 2. So I go over negative 3, down to negative 2. The next one is negative 1, 2. So I go over to negative 1 and then up 2. The next one is 3, 10. So I'm going to have to go off the graph. This would be 7, 8, 9, 10. And then the last one is 5, 14. So I'm going to go 1, 2, 3, 4. All right, and there's my line. Questions on that part of it? Okay, so at your boards, what I want you guys to do is fill in these function tables. And remember, just before you go up really quickly, f of x is the same as y. And these right here, which looks like thick negative signs, are actually the equal signs. They just got cramped in the zooming. Okay, so those are your equal signs. Go ahead and do those 4. You can plot them on the same coordinate plane. Okay, so when you were graphing all of these, they were over a very specific domain. So they gave you 5 domain values, and you found the range values for that given domain. What would you do if you had a problem like this, where I just said graph y equals 2x minus 5? What would you do if I asked you to graph that? I don't give you a domain, so what do you think you should do? Montrell? Make your own domain. Pick your own domain. Of all the numbers in all the world, you could pick your own domain. Which number should you pick? Maybe 1, 2, 3, 4, 5. Which number should you not pick? A million, 20,000. Why not? Like, are they going to work? Are they going to give you a range? Yes, but then you have to draw a coordinate plane that goes to 20,000 and negative 800,000 or whatever. So if you pick huge numbers, you're fine to do that, but then you've got to draw a huge coordinate plane. So my recommendation is not to pick giant numbers. However, I'm going to ask that you pick 5. You're going to have to do 5. And I'm going to recommend that you pick a couple negatives and a couple positives. So whenever I do this, I pick these 5 numbers. Negative 2, negative 1, 0, 1, and 2. Why do you think I want you to pick some negatives and some positives? So you can learn? Okay. Sometimes graphs do weird things at the negatives. Sometimes, like Brendan, you and I were talking about what type of graphs? Parabolas, right? And it's hard to tell if a graph is linear if you don't dip into the negatives to see what happens. Because sometimes when you go into the negatives, it'll all of a sudden become a parabola, or if it's an absolute value, it becomes a V. All right, so to test if it's linear, you really need some negatives and some positives. So right here, this is the domain that I always pick. Negative 2, negative 1, 0, 1, and 2. Now, technically, am I going to mark you wrong if you don't pick that domain? No, absolutely not. But this gives you a good way to see an accurate depiction of what that graph is actually doing. So choose your domain, pick your own domain, and then do it exactly the same way. Take each of those values and do what with them? Plug them in for x, figure out your y's, and then go from there. All right, so graph this function. Is the y by itself? So do I need to do step 1? No, so I don't need to do step 1. So for step 2, I just need to pick my own domain. What domain am I going to use? 1 and 2. Okay, and from here I just need to plug them in. So here are my x's. I plug in negative 2. 2 times negative 2 is? Negative 4 plus 1 is? Negative 3. Good. All right, I plug in negative 1. 2 times negative 1 is? Negative 2 plus 1 is? Negative 1. 0 times 2 is? Plus 1 is? 1 times 2 is? Plus 1 is? 2 times 2 is? Plus 1 is? And then step 3, what do? I graph it. So my first point is negative 2, negative 3, which starts right here. My next point is negative 1, which is right here. My next point is 0, 1, which is up here. And then 1, 3. And last but not least, 2, 5. I'll say this, a lot of people are mixing up their 0, 1 point and plotting it at 1, 0. Remember, your x is first. So if the x is 0, that means you don't move over at all, you just move straight up. Is this a linear function? Yes. This is a linear function. Angel.
Can you just where it says plus 1, can you just go in the y line?
Man, Angel, are you about to get into a whole thing on slope-intercept form? Like how to graph the line without plotting these points? Like put this one, and then what were you going to tell me to do? Plot the one and then what?
The rise and
Go up to.
Yeah, because you're giving me slope-intercept form? Yes, that's great. That's awesome. If you know how to do that, sure, except you're going to have to be able to fill out these tables at some point. So if you know how to graph them in slope-intercept form, by all means, yes. Okay? But we're going to get into that a little bit later. So if you're thinking like, I don't know what Angel's talking about, then keep doing it this way. All right? Do you know what he's talking about? Yes. Okay, so if you know that this is the y, well, you all should, because you all should have seen slope-intercept before, but if you don't know how to plot them, that's okay, all right? So you want to be able to find the domain. So on a test or a quiz, if I say fill out a domain table, that's what this means, okay? All right, how would you do this one? Same exact thing, right? Same exact thing. Do I need to do step 1? No, because y is already by itself. So step 2, I want to pick values. I'm going to do the same ones I always do. What's negative 2 squared? No. 4. Negative 2 squared is positive 4. Why? A negative times a negative gives you a positive. Okay, what's negative 1 squared? What's 0 squared? What's 1 squared? And what's 2 squared? 4. Okay, so when I plot this, my first point is negative 2, 4. My second point is negative 1, 1, 0, 0, 1, 1, and 2, 4. So what happened? Montreal? It's a V. It's a parabola. This is a parabola because this is an exponential function. So that's why I said you want to graph some negatives. Because if you only chose positive numbers, you wouldn't see the fact that it goes back this way. All right, so that's why I want you guys to do a couple negatives and some positives. And it's always good to do 0 for a couple reasons. 1, things do weird stuff at 0. And 2, it's easy. All right, because anything times 0 is 0. So 0 oftentimes is one of the easier ones. So this is why I always choose these 5 numbers as my domain, so that you can really see what's happening. All right, it keeps it small, it keeps it contained, and it also gives you any kind of weird stuff that goes on. So when this becomes a parabola, you can see that. All right, this is called an exponential function. Is it linear? No. Why is it called exponential? Because it has an exponent in it. All right, it has an exponent in it. And then that forms a parabola. Which looks like a V or a U. Okay, how can I use a graph to find a given value? So let's say, for example, I give you this graph. I say this is the graph of 1/3 x minus 3. Find f of x when x equals 6. How could I use the graph to do this? how could I use the graph to do this? Alejandro, what do you think?
I'm not sure about this, but can I actually just like look at where it's plotted and maybe like come up?
Yeah, you can look at where it's plotted. I want to look at where x is what? 6. So is that on the y-axis or the x-axis? I'm going to go over to the x-axis at 6, and I want to look at where the graph is. Where is it? It's at -1. So then the answer to that would be -1. Okay? The other way you could do it, the way we talked about doing it is yesterday, is to take this 6 and do what? Plug it in. All right, so you could take that 6 and plug it in, but if they give you the graph, this is easier, because you can just go right over and say, okay, where is x6? All right, what does it equal at 6? It equals -1. So then that must be, the answer would be -1. If I plug that in, I'll see that that's true, because 1/3 times 6 minus 3. What's 1 times 6? 6. What's 3 times 1? 3. What's 6 over 3? 2. What's 2 minus 3? -1. Okay, so if you plug it in, you'll get the same answer, but you can see it visually in this graph, so it might be a little bit simpler. So if you're a visual person, I think this tends to be easier. If not, and you want to stick with plugging it in, you can do that too. So for this one then, find f of x when x equals 2. Find f of x when x equals 2. So where is x equal to 2? I'm going to draw a line right down here. And I want to know where that f of x equals 2. It's right here at this line. So where does that happen? Well, here's the line. Where does it hit this line? At -1. So then my answer is -1. All right, so you just look and see where it hits that line. Okay. Do just one of these. Pick one and find it at your board. Pick one.